class. Today we're going to take notes on distance on the coordinate plane. This is going to be a little bit different than what we have been doing. I just want you to take the notes portion of it. When you get to the examples portion, you can go ahead and stop the video. We're going to go over those in class. I'm going to leave the examples on here for you to look at after class, but I want to go through those with you guys. So take the note portion and then stop. These are free-form notes again. Just due to time, I want you guys to focus on getting them down. I don't want to worry about any other format. So today, distance on a coordinate plane. So basically how we determine how far 2 points are away from each other on the coordinate plane. We're going to talk about two different techniques. The first technique is using right triangles. The second technique is using this thing called the distance formula. So after I'm done talking about each technique, I'll kind of briefly talk about the pros and cons. And then, like I said, we'll do the examples together in class. So when you get to the examples, you can go ahead and pause the video. All right, so distance on a coordinate plane using right triangles. So step one is graph the two ordered pairs, and then you're going to connect the points and label the segment C. So basically, you're going to put the 2 points on the graph and connect them using a straight line. That straight line, label it C. Kind of alluded to in step one, after you're going to use C as the hypotenuse of a right triangle, and then you're going to draw the legs of the triangle. So the legs will be a vertical and then a horizontal line. There's going to be two different ways of doing this. Either way, you'll get the same right triangle, it'll just be flipped. Step three is find the length of the legs. This requires you count. So you're going to look at the coordinate plane, you're going to count up or down or left or right to determine the length of those legs. Most students do this fine, but just be careful when you're doing that. It's an easy place to make a mistake. And then finally, after you have the legs of the hypotenuse, the right triangle, you can use the Pythagorean theorem to find the length of hypotenuse C. This length is the distance between 2 points on the coordinate plane. So most students prefer this technique. It is a little bit easier to do. It's less confusing. It doesn't have this intimidating formula involved with it, but it's got limits. If you're trying to find the distance between 2 points that won't fit on a coordinate plane, you really can't use this technique. With that being said, it's relatively straightforward. It's just finding the hypotenuse. Most of you guys have proven already that you're really good at that. So good option for points that fit on a coordinate plane, bad option if they don't. All right, second technique is using the distance formula. A lot of students just get scared of this thing when they look at it. It's really not that terrible, but I understand if you're looking at this, you're thinking, Mr. Robinson, why would you show me this terrifying monster? I want to cry, hide in a corner. I get it, but at the same time, it has its merits, and it's definitely something you're going to need to learn how to do if you want to get a 4 on your next assessment. All right, the distance D between 2 points, x sub 1 and y sub 1, and x sub 2 and y sub 2 is found by D equals the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. Basically, if you look at this, I'm going to go ahead and mark it up real quick. If you look at this, this will be one leg, and then this will be another leg. So really, you're looking at the distance between the two x points. Right here, you're looking at the distance between the two y points. All right, so and you realize, in the Pythagorean theorem, you square the leg, right? Here you're squaring the leg. You're squaring that distance. Same thing here. This is the distance between the y points, or the vertical distance. Just like in the Pythagorean theorem, you're going to square whatever that leg is. And then ultimately, when you're done squaring those lengths of the legs, what you do is you add them together, hence adding them together, and then you find the square root of them. So basically, this is just a different way of looking at the Pythagorean theorem, but it can be intimidating. Okay, a couple things we'll point out. Like I said, we're going to do examples in class. We're going to run through a couple of these together. The biggest mistake students make with this has to do with putting these coordinates into the distance formula. We're going to talk about that a little more in class. A really important thing to do is make sure you keep that sign. So example, if x1, or whatever point you determine as x1 is negative, you need to make sure you put that in as a negative. So that's one thing to look at. All right. Like I said, at this point, you can stop the video. We're going to go over the examples in class together. So if you can go ahead and pause the video, I'm going to continue doing the rest of it for you to look at later. But at this point, if you're in class, go ahead and pause the video. We'll talk about the examples together. All right. Now I'm going to continue. Okay, first example is to find the distance between 1, 2, and 4, 6. We're going to go ahead and do that using the Pythagorean theorem first. So I'm going to put my point at 1, 2. I'm going to put a point at 4, 6. All right, now following the procedure, I'm going to connect those with a line. So there's my line, right? And I'm going to go ahead and label that line C. All right, now I'm going to insert a vertical and horizontal line to represent the legs. So the key here is that these lines, it doesn't really matter the length of the line. So I'm going to go above that point and drop it down. There's my vertical line. And then I'm going to add another line that represents my horizontal line, kind of going right here. Now, if you wanted to, some people have that line flipped and it kind of goes up here. That's fine. Ultimately, it doesn't really matter. It'll be the same length of the triangle. All right, now we're on to the point we're going to count. So it doesn't matter which one I count first. Let's say I'm going to count the vertical change. So this would be 1, 2, 3, 4. Now, a lot of students will make the mistake of counting that and saying that's 5, because they'll say 1, 2, 3, 4, 5. Remember, you don't count until you move. It doesn't count as 1 until you've moved 1 unit. So 1, 2, 3, 4. I also like to make these little bubbles kind of as a reminder. Each bubble will represent a movement. So here it's be 3. So now we have a right triangle that has legs of 3 and 4, and we're trying to solve for C. So 3 squared plus 4 squared equals C squared. So this is 9 plus 16 equals C squared. 25 equals C squared. Square root of 25, C equals 5. Okay, so that's a Pythagorean triple. It's a 3, 4, 5. Pretty straightforward. Okay, now let's do the same thing with using the coordinates, using the distance formula. Okay, so it doesn't really matter which one you call the first point and which one you call the second point. The reality is it's going to work out to be the same either way. Since we're squaring this value right here, whatever we put in there is going to be positive. So for example, just looking at the x's real quick, I'm going to delete this. Let's say I call this x1, this would be y1. I call this x2, and this is y2. If we put it in that way, it'd be 4 minus 1, right? 4 minus 1 is 3. 3 squared is 9. All right, let's say we flipped it the other way. Let's say I put 1 minus 4. This time we get negative 3. A negative times a negative is still a positive. So it doesn't matter which way we put it in, I'm still going to get 9. So keep that in mind. Which one we call the first one, which one we call the second one, ultimately doesn't matter as long as we include the right signs. The right signs with those points, with the x and y points. All right, so D equals, and I'm going to plug this in theory, the right way. So we have 4, x2 is 4, minus x1, which is 1, squared, plus y2 is 6, minus y1, which is 2. Okay, so let's go ahead and simplify. So this would be 3 squared plus 4 squared. Now, if you look at this, these are really similar, right? Really similar. Okay, now D equals square root of 9 plus 16. D equals square root of 25. Look at that. The last step, we're doing the same thing, right? Square root of 25, square root of 25. D equals 5. Okay, so that's showing you can get the same answer using both techniques. All right, next one. This one we're just going to use the coordinate plane. This is a good example of time when you just would want to use the coordinate plane. There's no reason to use the distance formula here because it will fit. So I have negative 6, 3. So I'm going to put my first point right here. 6 to the left and 3 up. My second point is going to go at 3, negative 2. So 3 to the right, down 2. Now I'm going to go ahead and insert my line to connect the 2 points. For this line, we're going to label C. Go ahead and label this one C, right? And now I'm going to insert a vertical and a horizontal line. So like I said, it doesn't matter if I make my vertical line here or here. Either way, you're going to get a right triangle. So I'm going to go a little bit past where I think I need to go, and then I'm going to do the same thing over here. I'm going to go a little past where I think I need to go. All right, there's my 2 lines. This is a right angle there, and now we're going to go ahead and count. So all right, so I'm going to count here first. We have 1, 2, 3, 4, 5. That's 5. It makes sense. 3 above, 2 below, that adds up to 5. Okay, and I'm going to count this way, the 1, 2, 3, 4, 5, 6, 7, 8, 9. This also again makes sense. This is 6 to the left, that's 3 to the right. 6 plus 3 is 9. There we go. Okay, now I have my leg lengths, so I'm going to go ahead and set up the Pythagorean theorem. So 25 plus 81 equals c squared. 25 plus 81 is 106. Square root of 106. C is, we know it's going to be a little bit more than 10. C is approximately 10 and 3/10 units. All right, so that's using just the Pythagorean theorem. You could use the distance formula with this one as well, but you know, thought I'd alleviate a little stress. All right, now this next one is clearly one you want to use the distance formula, especially if you're using this graph, because negative 12, 10 won't fit on it, and 7, negative 12 won't fit on it. So in this case, we definitely want to use the distance formula. So put that back down there for reference. Okay, so it doesn't really matter which one I call x1, x2. Technically speaking, x1 will be the one that's furthest to the left, so this is definitely x1. This is definitely y1. Like I said earlier, though, if you flip it, it doesn't matter as long as you keep the right sign. All right, let's go ahead and fill this out. D equals, okay, so x2 is 7. So 7 minus negative 12, minus negative 12, okay, squared. Some of you might just say 7 plus 12, and that'd be perfectly fine, because remember, if you're subtracting a negative value, that's the same as adding. Now over here for the y, we're going to go negative 12 minus 10. Okay, perfect. So far it looks great. D equals, okay, 7 minus negative 12, 7 plus 12, so this would be 19 squared plus negative 12 minus 10. Negative 12 minus 10 is negative 22. Negative 22 squared. Remember, the negative isn't a bad thing, because a negative multiplied by a negative is indeed a positive value. So we have D equals 19 squared is 361. Negative 22 squared is 484. So remember, if you're entering this wrong into your calculator, it will give you a negative value. It doesn't matter what your calculator says. A negative value squared is a positive. We're into, later when we're talking about this in the high school material, we'll kind of talk about the one exception to it. In this scenario, it has to be a positive. All right, so 361 plus 484 is 845. The square root of 845 is approximately 29 and 1/10 unit. Okay, so there's an example of, right here, example using both techniques. Here's an example of just using Pythagorean theorem, and finally one of just using the distance formula. I would recommend that you guys, if you want to pick one technique to really master the distance formula, because it will work regardless of what you're doing. All right, hope you found this helpful, and I'll see you in class. Bye.